Hey guys, so let's start. So good afternoon, everybody. So last time I started to explain latches and flip flops. It's very simple. Every latch or a flip flop is actually a storage unit that can store one bit. Okay, so storage unit that can store only every latch can store one bit. Every flip flop can store one bit. There is a small difference. There is a small difference between latch and the flip flop. I will tell you about. Okay, so but keep in mind once you turn the power off, whatever is stored is lost. Okay, so last time I started with so here. Last time I started with SR. Last time I started with SR latch. Okay. So here the first we created it. You can create or you can design SR latch using NOR gates or NAND gates. Okay. So what we did when we created it using NOR gates, as you see here, okay, we have two inputs this way, and we have Q and Q prime. Q is the stored value. So here, so this latch gives you the stored value, either 1 or 0, and also gives you the complement of the stored value. You can understand? You may not need both of them, but it depends. Sometimes you need both of them. Okay, so you have the two options. You have the stored value and you have the complement. Use based on your design. Use which one? Okay, the one you like or the one you need. Also here, as you see, we have two inputs. One we call it set. The other one we call it reset. And if you look how it works, as I explained, this one actually here, as I told you last time, this one is actually active hard, which means we have S and R. So S and R, these are two inputs. They can be used to change the stored value. So by stored 0, you can make it 1, you can make it 0 again. So you have control what is the stored value. Okay. So as I told you last time, if this is 1 and this is 0, okay. So what's going to happen here is going to be you are set. Why? Because this one is active part. So whoever is 1 is gonna take action. So here, if R is 1 and 0 is here, so actually you are making reset. Okay. Also, I told you last time, 0, 0 actually not change. So if the input is 0, 0, not change. If it is storing 0, it's gonna continue 0. If it's storing 1, it's gonna continue 1, not change. Okay. Also, I told you 1, 1 is forbidden case. You should not use it. Because if you put 1, 1, I will get 0, 0. So Q and Q prime equal to 0, 0. And this is forbidden because always Q prime, this output here, this output has to be the complement of this one. Is that okay? That's why this we call it forbidden. Forbidden, that means you should not use it. Also, we created the SR latch using NAND gate this way. It's almost the same thing, but we found this is also Q prime, we have R, S, we have R as well, but this one actually active low. Active low means this is SR, so this is 0, this is 1. So it's gonna sit because this is active low, okay? In this case, it's gonna become 1 because if this one is 0 here and this we have 1 here, so actually you are gonna make reset. I'm gonna stop 0. Okay. Here, 1, 1 is actually not change. 0, 0, this is the forbidden case. Okay, because if you put 0, 0, you will get 1, 1. Q equal to Q prime, and this is not allowed. Is that okay, guys? So this is a very basic architecture. I'm gonna build on this one, as you will see right now. Okay. So this we call it SR latch. Today, I will show you now how I can add enable to this latch here, to this SR latch. So here, I will do very simple thing. So this is the original latch. Okay, this is the latch here. Okay. So here I want to add enable to this latch. All what I will do here, I'm gonna do here NAND also, here also NAND, and then here you have here is the enable, and you have here S and R. So all what I did, I just added this part. So if I add this part, and you see here, if I added this part here, okay? So if you see, as you know, if in case of NAND, if one input is 0, so regardless of the other input, the output is 1. Is that okay? That is why if the enable is 0, this is the enable, to enable or disable. You know, you already had this concept before, the idea of having an enable in any device. We like something like that in logic circuits to have control on the circuits. You can turn it on or turn it off, okay? So here in this case, let's see how it works. So if the enable is 0, so regardless what you have here, regardless what I have here, I will get 1, 1. And you know 1, 1 is gonna make no change. Okay, if you go back here, you can find 1, 1 is no change. Is that okay? That's why you see if the enable is 0, this is that means you are disabling it. What to mean by disabled? That means you can't change the truth value. So even if you make a set, you make a reset, it's not gonna work because it is disabled. This is the idea of this, the meaning of disabled. You cannot change the truth value. Okay, but if I put here, if I make the enable 1, you know also from NAND gate, if one input is 1, the other one is X, I'm gonna get X prime. So what happens here, I'm gonna get here S prime, and I'm gonna get here R prime. Is that okay? Because this is S prime and this one is R prime, it's not S and R like this one is and R. But here is S prime and R prime. So what's gonna happen is that this one is active low. Now it's gonna become active high because of this prime, okay? That means, let's see, if S and R, if S, for example, is 0, R is 1, okay? So that means S prime should be 1, R prime is 0, okay? That means it's gonna be, remember here, this part here was active low, okay? As you see here. But because here, yeah, so here, if this one is active low, but here when I input prime and prime, it becomes active high. Okay, so what happens here, as you see, when I input 0, 1, it becomes 1, 0. And here in this part here, that means because this part is active low, but everything is active high. So actually, so this one is gonna make a reset. Q should equal to 0. So that's why if you just look at R and the Q, you can see it becomes active high. Okay. So anyway, so this is again, also if you put here 1 and 0, if you put here 1 and 0, so this one here Q is equal to 1, okay? The other things we have here is when you have 0, 0, should be no change. Still we have 0, 0, no change. 1, 1 is forbidden because if you have 1, 1 here, okay, so I'm gonna have 0, 0 here, and 0, 0 means I will have 1, 1. So this is a forbidden case. Is that okay? So let me go to the slide to show you. Yeah. So as you see here, guys, this is just it's our ledge. I just added this part, okay, to add enable. And this is the truth table. Look how it works. If the input is 0, if the enable is 0, so regardless if you are making set or reset, it doesn't matter, there should be no change. That means no change means if Q is equal to 0, it's going to continue 0. If Q is equal to 1, it's going to continue 1. No change. Okay? So regardless if the reset is not going to work, set is not going to work. Okay. Now, if you enable it, okay, now it's going to work, but this time it's going to work as active high, not active low, because this inversion will put it here. Okay. So that's why you can see here, if you make here 0, 0, 0, 0 actually means no change. Yeah, that's what I'm saying here. So 0, 0, no change. That's why 0, 1 should stay 0, 1. Okay. And then now, if you have one here, if you have one here in R, so actually you are making a reset. If you have one here, you are making a set. 1, 1, this is the forbidden case because it should be 1. Any question? Again, I started from a very simple one, and then I added enable. Okay, guys? Okay. Also, this is an interesting part. You see, I started with a very simple one, and then I modified it to make this one. I will also make some change here to make a new latch. Okay? Then the new latch, I will use it in flip-flop. So I'm gonna build, so here, every time I add something, and then I use it, okay? So now, yeah, let's first look at this one. Because I told you it's a coming quiz, but it will be about flip-flop. It's not gonna be about latches. I will give you a chart like this one, and then I will give you S and R. I will give you part like this one here, okay? And then I will ask you to do this one. But anyway, let's see how we can do how can we do it here. First of all, you can see in this part the enable is 0. Enable is 0 in this part. So what it means enable is 0? It means no change. So here I don't need to look at S or R. I don't care about S or R. Enable is 0. So that means when the input is high, it has to continue high. Here, sorry, this is low, and this one is high, it's gonna continue high, no change. I don't need to even look at this or R because it is disabled. Make sense? Now, I enabled it. So now, here it's gonna work normally. Normally means, look at this here, normally means 0, 0, no change. Is active high. So here, 1 at R, so this one becomes reset. 1 at S should be set. Okay? One should not have it. Okay? So that's what I will do right now. So if you see here, so now it's gonna work. So if you see here, this is 1 and 0. This one is active high. So this should be set. As you see here. After that, 0 and 0. 0 and 0 no change. Because if it's 1, it's gonna continue 1. Is that okay? Now, this is 0 and 1. Okay, active high, so it has to be a reset. During this time, it is a reset. Now it is 0, 0. 0, 0, no change. Because it is 0, it's gonna continue 0, no change. 1, 1, okay, this is the forbidden case. Now, this is the case you should not use. But if you use it, 1, 1, so you will have here high and high. Both of them are high, that's why you shouldn't be used. Okay? Then after that, we have here 1 and 0, so it's gonna be set, okay, because it's active high. So it's already 1, so it's gonna continue 1, and this one becomes 0. 1 and 1 again should be 1. Okay. Any questions? Nothing is new. Just I'm just applying the this table we call it characteristic table. So we'll just apply this characteristic table. Okay, guys. Any questions? Okay. There is something I'm gonna tell you about. It's called indeterminate condition. Okay. So what happens here? I will tell you. Okay. So for example, here, guys, if the enable is 1, so here if it is enabled and S is 1 and R is 1, which is the forbidden case, okay, or the case you should not use. What happens if I use it? If I use it, I will get here 0 and 0, and then I get 1 and 1. Is that okay? If you use it, okay. Then what happens after that? Now, if I move from this case here, okay, and now I make the enable 0, what's gonna happen? Okay, so now we still have 1 0 and 1 0. Is that okay? What's gonna happen? What's gonna happen here? The output is indeterminate. The output can be 0 or can be 1. Indeterminate. Okay, why it is indeterminate? Because it depends on which gate is faster than the other one. Let's explain. So for example, if this gate is faster, okay, and what happens here? 1 and 0, so we are gonna get 1 here, okay, and then here 1, and then we already have 1 from here, I get 0, and this 0 here actually is gonna 0, I will get 1 here, okay? But if this one is the faster one, if this one is the faster one, what happens here is we have here 1 and 1. I did 0 here, and this 0 is gonna force this gate to be 1. So again, what I want to say in this slide may not be very important, but what I want to say is, again, I will say it again. So what I'm saying here is, if this latch is enabled and you put the forbidden condition, which is 1, 1, okay, you will get 1, 1, okay. However, if after that, if I change the enable and make it enable, what value you will get here is actually indeterminate. I can't tell 0, I can't tell 1. Why? Because it depends on which gate is faster. Because the faster one, if this one is faster, okay, so this one, the 0 will come here first. So once this 0 comes here first, it's gonna force the other one to become 1. But if this one is faster, okay, so the 0 will come here first, and this one is gonna force the other one to become 1. So that's why we call it indeterminate condition. Again, I don't think it's, I need to explain it, but I don't think it's very important because we should not use 1, 1, we should not use it anyway. But just in case we use it and we change the enable, in this case, I don't know what is the hour because it depends on which gate is faster. Okay, any questions? Okay, so now as you see, guys, all what I did, number 1, I started from this SR ledge, this number 1. Number 2, I added this part to add enable to it. This is number 2. Number 3, now I'm gonna use this ledge. I'm gonna modify it a little bit to create a new ledge. We call it D ledge. Okay, so that's what you will see right now. So what I'm gonna do right now, as you see here. Yeah, so this ledge here is just very similar to the previous ledge. All what I did in the previous ledge, this was it, this was out. All what I did, I just added this part here. Okay? And now it has only one input. And this ledge, we call it D ledge. Okay? I added only one input. Sorry, it became now it has only one input. Okay? Okay, let's see what cases I have here right now. Number 1, is that okay, guys? Any questions? So this is similar to the SR ledge I have just explained. All what I did, I just added this part here. So instead of having SR 2 inputs to this ledge, we call it D ledge. This, as you see here, this ledge has only one input. Only one input, D. Is that okay? How it works is still in this ledge, but instead of 2 inputs, this one has only one input. Let's see how it works, and also it has enable. Okay. Let's see how it works. Number 1, if the enable is equal to 0, okay, so regardless of what you have here, regardless what input what D is, so actually you are gonna get here 1 and 1, and then no change. So as you see here, this is a characteristic table, as you see here. When the enable is 0, so regardless of the value of D, no change because it's disabled. Make sense? Now, if this one is enabled, so now I have 2 options. Either D is 0 or D is 1. Only 2 options. Make sense? Let's see. If D is 0, so actually this one becomes 0 and this one is 1 because we put inversion here. Okay? And you know, from the if this one is 0 and this one is 1, if this one was R, if this one was R, that's what I did here. It and R. So if you come here, it and R. So now it becomes, you have 0 and 1. And you know this part is active hard. So now it becomes a reset. So when D is equal to 0, I'm going to store 0. Okay. You see what I did, guys? So if I put here, if input is 0, so this one is 0, this one is 1. Okay. And then 0 and 1, so that if you already know how this one works, this one here, so S. Yeah, you can consider this input S, you can consider this input R, okay? And because this one is active high, R is 1, S is 0, so this one should reset. So or U equal to 0, okay? Now let's see if I put here 1. Okay, if you put 1 here, and this is S, and this is R. Okay, so X is 1, and sorry, this is R here. R is actually 0. And you know this one here is actually active high because S is 1 and R is 0, so it has to be set. Make sense? So this one is similar, just similar to this one here. Okay. All what I did, I just added here inverter this one. And because of that, I have only 2 cases. Either 1 here, 0 here, or 0 here and 1 here. Based on the input you have. Okay? So let's tell you the conclusion, because this now it became very simple. So now the conclusion is, number 1, if enable equal to 0, it is disabled, so no change. This is number 1. Okay? Number 2, if enable equal to 1, that means it is enabled. Look how it is easy. If D equal to 0, Q equal to 0. If D equal to 1, Q is equal to 1. That means Q equal to D. Very easy. So if I want to store 0, I have to put here 0. If I want to store 1, so I have to put here 1. Okay? This is the characteristic of this. Any questions? Okay. Yeah, just here I'm explaining how it works. So in the first part here, guys, you can see the enable is 0. So it is disable. And you know disable means regardless what is D, the value of D, regardless. So now no change. So if Q is 0, it's going to continue 0. If it is 1, it's going to continue 1. 0 is going to continue 0. 1 is going to continue 1. Okay? Because it is disabled. So in this part here, it is enabled. Okay? Very easy. So as you see here, when it is enabled, if D is 0, okay, and the current Q is 0, so I will, regardless what is the current Q, regardless what you are storing right now, if the input is 0, so I will store 0, okay, reset. And if D is 1, so regardless whatever you are storing here, regardless, the output is 1. Okay. So here the difference, this is the current stored value before we apply D, and this is the new after I apply D. Okay? So here, if D is equal to 0, so regardless if you are storing 0 or 1, it doesn't, this is the old value. After I apply D is equal to 0, I'm gonna get 0. Same thing here. When I apply D is equal to 1, I'm gonna get 1. Same. Any questions? Also, we can implement the same thing, something like that, but instead of using NAND gate, I can use NOR gates this way. So here you have NOR gates here, but here I'm gonna use AND gates instead of NAND gates. So instead of NAND gates, I'm gonna use AND gates. In this case, you will get the same truth table here. It's also active. So it's also it's exactly the same thing. So here you can see if the enable is equal to 0, no change. If it is enabled, if D equal to 0, okay, so we are gonna make a reset. If D equal to 1, we are gonna make a set. Okay, for sure that's what you see. You don't see this is something internal. So what you have, I have a device this way, we have Q and we have Q prime. And then I have enable and I have D. That's it, very simple. If you want to store 0, just D is equal to 0. If I want to store 1, just D is equal to 1. And I can do it using NOR gates as you see here, and then I can do it using NAND gates. You can see, so what I want to tell you guys, I started with something very basic, this part. This was very basic stuff. And then I added this part, and then I added this part to create D latch. Okay. Any questions? Okay. So now let's see how if you have a diagram like this one, how it works. Okay. Number 1, very easy. Look here, guys. Here, enable is 0. Enable is 0. What? So that means regardless of the value of D, if Q, so here I'm assuming we start from Q is equal to 0, so it has to continue 0. This one has to continue 1, regardless what is the value of G, because it is disabled. Make sense? Okay. Now, here it is enabled. Because it is enabled, the way this latch works is Q is equal to D. D is 0, Q is 0. D is 1, Q is 1. That's why you see here, this part here, D is 0, that's why I did 0. And now D is 1, now it becomes 1. Okay. And here, yeah, in this part, it is disabled again. I disable it. So no change. The last value here was 1, it's going to continue 1. The last value here is 0, it's going to continue 0. Okay. Okay, now this part, it is enabled. When it is enabled, as you see here, guys, very easy. U is equal to G. U is equal to G. Okay, you put 0, you get 0. You put 1, you store 1. You put 0, you get 0. Okay. And usually Q prime is very easy, just the complement of Q. Okay. Now in this part, it is disabled here. So because it is disabled here, so actually whatever the value of here is going to continue, it's going to continue the same. Okay. Regardless what you have here. Okay. Any questions? Very easy. This one is very easy. Why? Because it's just look at the table. Very simple table. Q is equal to G. If you want to store 0, just put 0 in G. You have only one input. Okay, guys. Any questions? Okay. So now let me summarize what I finished latches. I will start the flip-flops right now. Okay. You will see again. I'm gonna build the flip-flops using the last circuit I had here. So I'm gonna use this circuit as a block D flip-flop. I will use it to D latch. I'm gonna use it to create flip-flop. Okay. So let me summarize what I did so far, guys. Number one, I started from this very simple circuit. I call it SR latch. Okay. And then I can also implement it using names as I did here. After that, I just added this part here to add enable. So this one is SR latch with enable. And then I took this one to create D latch. I created D latch by just adding inverter here. And in case of D latch, we have only one input. As you see, I just added this part here. Okay. So it has only one input. Any question? After that, I will use the D latch to create flip-flops. Okay. So before I continue, so now I'm gonna start teaching flip-flops. So number one, what is the similarity and what is the difference between latches and flip-flop? Okay, number one, the similarity. Both of them are storage units. So if you have a latch or flip-flop, both of them are used to store 1 bit. Every latch stores 1 bit, every flip-flop stores 1 bit. This is similarity. What is the difference? The difference is the latch is not synchronized, but this one is synchronized. This is the only difference, and this is the most important difference. Okay? As you will see right now, to create a flip-flop, I will use latch inside it. So I will use latch inside the flip-flop to create flip-flop. Okay? You will see that right now. But first of all, tell me what you mean by not synchronized and what you mean by synchronized. I will tell you. Okay? For example, if you have D latch, if you have a D latch, okay, I told you here in D latch, Q is equal to G. That means when I put 0 here, I'm going to store 0. If I put 1, I'm going to store 1. Every time the input changes, the output is going to change immediately. This is the main difference. Okay? So here what happens, every time I put input, I will get the new stored value immediately. But for flip-flop, for example, again, we are going to have also D flip-flop. So here we have D latch. Also, we have D flip-flop. Okay. What is the difference between D latch or D flip-flop? The difference is here in flip-flop, still Q is equal to G, similar to this one, Q is equal to D. But when I put input here 0, for example, it's output here 1. Okay. So I'm not getting. This value is going to be changed to 0 in specific times. That's why I put synchronized. This is the main difference. So here, the main difference when I apply 0, I'll do 0 right away. When I put 1, the change will happen immediately. Here, because I need synchronization. Synchronization here means I want the change to happen not immediately. I want it to happen in specific times. That's why when you apply a 0, it may take some time until you see 1 here. Okay, when the time comes. Okay. What do you mean by specific time? Can you give me details? Okay. Actually, to do that, I'm going to input a signal here. We are going to input a new signal here. We'll call it a clock. Very important thing, clock. We use it all the time. By the way, you already use this clock in your life. You know when you buy a laptop, and they tell you it's 2.5 gigahertz. This is the frequency of the clock of the system. You get what I'm saying? So what is the clock? A clock is used to achieve synchronization. So what it means, I will tell you what it means. Okay. Number 1, clock is a square wave signal. Okay, square wave this way. Okay. So it is used for synchronization. Synchronization means we have 2 types of the clocks. We have 2 types of them. So here we have positive edge and negative edge. Let's assume first positive edge. That means all actions should be taken here at this time. Specific times. You remember when I told you what do we mean by synchronization? Can you clarify what synchronization means? Synchronization means actions have to be taken in specific time so that we can be synchronized. Okay? If you are better than me, you are not going to take action, then I will take it later. No, all of us are going to take action at the same time. Okay? So this can happen by having a clock, something like a square root like this one, and all the circuits in the system using the same clock. So if you have a big system, all of them are using the same clock, so that only actions are going to be taken here in specific times. Okay, that means if I apply 0 here for G, for example, if I have a flip-flop here, and we have G here, U is equal to 1, and now I want to make it 0. But I did it here during this time. The action is not going to be taken immediately. The action will be taken here. You understand what I'm saying? So always, as action, the change of the Q value has to be done in specific times, which can be rising, or as I told you, you can design it. This is something you can design. This one is we call it positive edge. Or this is something you can design. We can take the action at falling edges this way. So here action would be taken. Usually any system either this one or this one. Okay? But again, let me make it simple. Look here, guys. Usually for any digital system, we use a clock. You need to understand the concept of a clock. Okay? The concept of a clock is just a square wave. Okay? This clock is connected to all the circuits in the system. All the circuits are using the same clock, and it is used for synchronization. Synchronization means we want to do something at specific times. All of us. Okay? I want to avoid that one circuit is gonna produce some value faster than other one. No, all of us are synchronous. Okay. So that means even the input change here, only you will see the output is in these specific types. Okay. So we have 2 types of systems. One we call it positive edge or negative edge. It depends on when action is taken. If the action is taken at rising or only rising or only falling. Is that okay? Any questions? This is the main difference between G flip-flop and G left between latches and flip-flop. So let me say it in a very simple sentence. Latches. Every time you change the output, every time you change the input, the output changes immediately. This is latches. Flip-flop, when you change the input, the output is going to be changed at the clock edge when the edge comes. Okay, 4 synchronous. That's why they are very close, but this is the middle. That is why, if you look at here, we don't need one input for a clock. This one has one input for a clock. Is that clear? Any questions? Okay. So that's what I'm going to explain right now. Any question, guys, here before I continue? That's why comparing to latches, you will see when I draw this. So here we don't have one input for clock, but for flip-flop we are gonna have one input for clock. Yeah, that's what I'm explaining here. We have two types of edge response. Okay, we have here positive edge or negative edge. So if it is a positive edge, that means the action is going to happen here at the rising specific times. But if it is negative edge, so actually the response here means the action or the response is going to be taken is actually at the falling edges, as you see. Right? All the circuit have only one clock. So all of the circuit is using only one clock. Okay. So let's start here for flip-flop. I'm going to teach, and this will be, the quiz will be about this. I will test you in flip-flops, okay? So in flip-flops here, guys, I'm going to teach you 3 types of flip-flops because that's what we are going to use later in this course. I'm going to teach G flip-flop. I'm going to teach JK flip-flop and T flip-flop. So I'm going to teach you 3 types of flip-flops. G flip-flop, JK flip-flop, T flip-flop. Okay? Let's start with the first one, G flip-flop. Okay? G flip-flop. I already had D latch before, remember? Yes, I will use it here, as you see here. Okay? Number 1, how D flip-flop is going to work comparing to D latch. It's exactly the same thing. So if you look here, guys, for D latch, okay? When D is equal to 0, I'm going to store 0. If D equal to 1, we store 1. It's the same thing here. If D is equal, if G is equal to 0, we're going to store 0, but not immediately. We're going to store 0 in a specific time when the clock is falling edge. So it's going to be exactly the same thing. If G is equal to 0, Q is equal to 0. If G is equal to 1, Q is equal to 1. It's the same, but this happens immediately. This is going to happen only at certain times. Falling edges or rising edges. Yes.
So a flip-flop is practically just a latch with a clock instead of a continuous enabler, right?
No, because if you see how I created it, I'm going to create it using 2 latches. You got what I'm saying? I can't say flip-flop is a latch, and then I can say both of them are stored units, but one of them latch is going to change immediately. The other one flip-flop, the stored value is going to be only at specific times. You got what I'm saying? But how can you make it? That's what I'm going to teach you right now, how I make it. Okay. So how it works is D flip-flop is exactly similar to D latch. It's almost the same way. When you hear when the D, when you can add enable, by the way, but here I just make it simple. I didn't add enable, but still you can add enable. Okay, if you want, you can add enable as well. Okay, but here if G is equal to 0, we make reset. If G is equal to 1, we make set. It's exactly the same thing. When G is equal to 0, you are gonna make reset. D1 is gonna make reset. But this one happens immediately. Once you put the 0, you will get 0. Once you put 1, you get 1. For this one. This one, no. You put 0, you have to wait until the time comes because actions are taken in specific times. Once the time comes, output is equal to 0. Okay? And so on. So number 1, how we drew it, and once I drew it, how I can know if this is latch or flip-flop? Is there something you can tell? For sure you can. If you look here, guys, we have only one input similar to latch. We have 2 outputs, Q and Q prime. Is that okay? On top of that, we have one input for clock. So every time you see one input for clock, so this is flip-flop. So if I remove this part, here, so this is D latch. Very simple. You got what I'm saying? So now, here we have one input for the clock. One more thing. How I can tell, because you told me for a clock, it can be positive here, take reaction here, and just rising, or it can be falling, okay, or negative edge. It can be something like this one or something like this one. How I can know? Very simple. Look here, guys. First of all, the clock, usually we are going to make a rectangle this way, okay? But if there is no bubble here, if there is no bubble, so this is actually going to be positive. So the action is going to be taken at rising edges. But if there is a bubble, if you see bubble here, so this bubble, first of all, this triangle here is actually telling you this is a clock. So once you see a triangle, this is a clock. If there is a bubble, so that means it is negative. So that means action will be taken at falling edges. But if there is no bubble, sorry, if there is a bubble, sorry, this is if there is no bubble, so it is rising. If there is bubble, it is negative, falling. Is that okay, guys? This is how can you tell if this is a flip-flop or ledge. This is how can you tell if it is a negative edge trigger or positive edge trigger. And again, this is something you can define. Whatever you want. You want to make it negative or positive, something I can define. And this is no difference between them. You understand? Don't think always there is something better than the other. Even when I compare ledge to a flip-flop, I can't say flip-flop is better than ledge. No. It depends again on which one I do. If you want to make a synchronization, so yes, I will use flip-flop. If synchronization is not a big issue and I want to do something else that needs the output to change immediately, so I will use ledge. So here I'm not saying this one is better than the other. You understand what I'm saying? Same thing here. This is something you can design, you can make it rising or falling. So now I will explain how I can create D flip-flop using D ledge. Okay, you will see very simple idea. Okay, so the idea here is, you remember how D ledge works? Yeah, this is how D ledge works. Okay, so the idea here to create a D flip-flop, instead of using only one D ledge, I will use two. Okay, this one I'm gonna call it a master. This one I'm gonna call it a slave. Okay, you understand why. Okay, and then I will connect the enable this way. Put here inverter, connect it to this enable. Okay, so what happens here is, look here, guys. So here, so this is the flip-flop this way. Again, this one is negative edge. Okay, so what happens here? Whatever you have here, I have to see it here. Whatever you have here, I want to see it here. When every time there is a falling edge. That means if I put one, this one has to jump from here to here when there is a falling edge here. Okay, how it happens, I will tell you how it happens. Look here, guys. When I put here one, okay, and this one, the clock is high. Because the clock is high, so this one is enabled and this one is disabled. And this one is gonna jump from here to here. But I'm not gonna see it here. Very simple, very simple. So when the input is high, so the master is enabled, whatever you have here is gonna jump into. But it's not here yet because this one is disabled. Very simple. And now, when this one to move from high to low, at the moment it moves to low, now this one becomes 0. So this one is disabled now. Okay, and this one becomes 1, so this one is disabled, and this one is gonna make the second jump. Very easy, right? It's gonna make the second jump here. So in order, so again, we need high to make the first jump from here to here, and then I need low to make a second jump from here to here. That's why I need high to low. Any questions? Easy, right? Any questions? Let me ask you a question. What if I want, that's why I'm telling you this is just a very small difference. If I want to make it instead of negative edge, I want to make it positive edge. How I can modify this one to make it a positive edge? Yes. Yes, thanks. So we have to move the inverter. So for example, I'm going to remove it from here. I will put it here. How? Is it very simple this way? The answer is yes. Okay, I just remove it from here. How? I will tell you how. So what happens here? Number one, here, if you have here, for example, 0, or any number, 0, or 1 or 0, or make it 0, okay? So here, in order to enable the first one, the clock has to be 0 to enable the first clock, to make the first jump to here. Make sense? And then, once this one go to 1, So here, this one becomes enable and makes the second jump. Very simple, right? Yes. So you can, if you want, if you are designing it, I can just make it remove the inverter from here too. Is that okay? But let me ask you a question. What if I'm not designing it, but I already have a chip? I have a chip, and the flip-flop I have is actually negative H. How I can convert it to positive H? So I don't have access to the circuit. I just have a flip-flop. I'm just using it. You understand what I'm saying? So I have a flip-flop. I can go inside and modify it. It's a chip. Okay. How I can convert this one from negative H to positive H, or the opposite. Yeah, just to put inverter here at the output here, at the input here. You know what I'm saying? So just by putting inverter here, any clock that's this way, I'm gonna make it this way. Okay, so here. Okay, so when this one is rising after the inverter, it becomes falling. Okay, and so this one will trigger this one. You got what I'm saying? So again, so if you have a positive H flip-flop, you can add inverter to convert it to negative H. If you have a negative H, you can add inverter to make it a positive H. Very easy, right? Any questions? Okay. So let's see how it works here, guys, using the diagram. So if you see here, first of all, this is in. So as I told you in the coming quiz, I will teach 3 flip-flops. Okay. For each one of them, I will give you a diagram, something like that, and then I will ask you. I will give you clock, give you input, and then I ask you to give me Q. Okay. How this one different from the ledge? I told you if this is the clock, and I tell you if this is the clock, and then I tell you this is negative H, that means that it changes has to happen here. So you don't need to think anything in the middle. Don't think about it. You need to make decisions only at this moment. At this falling, this falling, this falling. You get what I'm saying? So in exams, in anything, this is the way you have to do it. Okay? If I tell you this is a falling, so you have to look at this moment, because the output is not going to change in the middle. Okay? So let's look at this exact moment here. Okay? So if we start the Q is 0, so it's going to continue 0 until we hit H. In the H, I need to decide it's going to continue 0 or not. Okay? So here, because this one is very easy, Q is equal to G. Okay, so now at this specific moment, G was 1. That's why Q has to be 1. Okay. Now don't think about it here in the middle. So even look here, this is look here, D changes, but Q is not going to change. If you go to ledge, if this is a ledge, if this one it changes this way, this one has also to change. Okay. So for example, here in this part, so this is the main difference between ledge and so if this is a ledge, what would you see? This one is high, high. This one is low, so this one has to go to low. Okay. This one is 0. This is 0. This one is high, has to go to high. Okay, because it's a ledge. But here, because it's not a ledge, it's a flip-flop. Only changes happen in specific moment. So even if G changes here in the middle, no reaction. The action will be taken in a specific moment. So now, here, in this one here, G is 0. So Q has to be 0, as you see. Okay. Again, also I will do it here. Here, in this moment here, no change in the middle here. Okay, I repeated it multiple times. You only look at specific types. Okay. Here, when this one is 0, so this one is 0, G is 0, so Q should also equal to 0. Any questions? I think I have another example, okay, just to understand better. So nothing new, just another example. You have here a clock, guys, this way. I am telling you the clock. This is not something you can guess. I'm telling you, or unless I give you a figure, you can guess from the figure. But if I give you a block, like this one, if I give you a block like this one, I don't need to tell you this is a positive H or negative H, because you can tell from here. Okay. But anyway, so here I'm telling you it's a falling H. So action has to be taken here Action has to be only changes should happen here, only at falling, okay? So let's see how it works. So we start, first of all, we start from 0. Okay, so it's gonna continue 0 because only changes happen at this moment, okay? So at this moment, D is 1. So here this one has to go to 1. And it's gonna be the same regardless what happens to D. I don't care what happens to D because action will be taken here. Here D is 0, so this one will go to 0. Okay? Same thing here at this moment. I don't care about, don't look at it. I don't care about it. Okay, action is taken here. This one is high, so this one has to go to high. Same thing here. Only action taken here. This one is high, so it's gonna continue high. At this moment, it is low here, so this one go to low. Okay. At this moment, this is 0. Okay, guys, that clear? Any questions? Yeah, good. Yeah, here I'm asking you how can you make positive H. So it's the same thing I already explained it. The way you can do it, you can put the inverter here, as I explained, or if you already have a latch that is falling H, you can add inverter here in the clock to make it rising. Any rising, you can make it falling, any falling, you can make it rising. You can switch it by adding inverter. Okay? Any questions? Yeah, here I give you another example for rising H. It's the same thing, nothing is new, other than here we are going to take action at the rising H. Action should be taken here, only taken here. Okay. So here at this moment here, D is 0, so Q has to be 0. And it has to continue 0 until this time comes. At this specific time, now I will think about it. This one is high, so this one should be high. And it's gonna continue high. I don't care what happens to D. Okay, this is a major difference between latch and the flip-flop. Look here, D change it to 0, but this change will be reflected at this specific time. But if this is a latch, it would be immediately. You got what I'm saying? So anyway, so here now D is 0. So at this specific time, this one becomes 0. Okay. Here, at this time, D is 0, Q is 0, because this flip-flop is very easy. Q is equal to D, but at a certain specific times, okay? Or to be more accurate, Q if T plus 1 equal to D of T. This is more accurate than this one. That means this is the new Q. The new Q equal to the current D, but when the time comes. This is the new value. This is the current value for D. Or let me be more accurate. Okay, this is when because this is the way we are gonna write it later. If you have an H, so whatever happens after the H, we call it T plus 1. Whatever happens before the H, we call it T. Okay? So whatever value just before the H here, okay, it's D of T. Anyway. Oh. Same thing here, as we see here, guys. This one, D is 1, so Q should be 1. Any questions? Again, in the coming quiz, I'm gonna give you the clock, I will give you D, and then I will ask you to draw Q and Q prime. Always Q prime is the opposite of Q, always. Because, and this is maybe the advantage of using D flip-flop. Do you have a forbidden case here? We don't have a forbidden case. What I'm saying? So in case of D flip-flop, we don't have a forbidden case. Either 0 or 1. Okay? But you remember in SR, we had a forbidden case. When you 0, 0 or 1, 1, this created a forbidden case where Q is equal to Q prime. It's not allowed. Any questions?
Will you tell us if it's rising edge or falling edge?
Yeah, for sure. I have to tell you. Either I tell you or give you, if I give you this block diagram, you can tell, right? So this is one is positive H, this one is full H. Other than that, you can't get something like that. Okay? So I have to tell you if it's rising or falling for sure. Any questions? Okay. So this is a very basic D flip-flop. I can modify it more if I want. So this is the block diagram for the D flip-flop. We know how it works. If D is equal to 0, Q is equal to 0, but a specific time. When G is equal to 1, Q is equal to 1 in a specific time. This is how it works. I can add, I can modify this circuit more to add more things. And that's what you should find when I think in the coming lab, you are going to use a chip. This chip has flip-flops, okay? So sometimes we can design, this is a very basic one. We can design it to have more inputs. I will tell you what these inputs are doing, okay? Let's understand. So that's what I'm saying here, flip-flop with additional inputs. So I can design it so that, yeah, so this is a flip-flop, this is a clock, this is okay, we are familiar with this one. This is Q, okay, this is a basic one. We should have Q, we should have Q prime, we should have G. These are the basic ones. But I can add 2 more inputs. Okay, I can add 2 more inputs. One input we call it clear. One input is called preset or set, preset. Okay, guys? So I can add 2 more inputs. One is called clear and one is called preset or set. Okay? So what? Number one, what these inputs are doing and how we can use it. I'm going to tell you how. Sometimes, guys, for initialization, for initialization, in the very beginning, I want to clear the clock. I want to start from 0. I don't want to wait until I receive a clock before the clock. I want to clear it immediately because this is initialization. Don't wait for the clock. Okay? Usually, when we work at the clock, this is the normal operation. Okay? But for initialization, usually in the very beginning, I want to start from 0. Okay? So that is why we have here 2 inputs. One input here, we call it clear, and one input here, we call it set. So this one is going to clear the flip-flop immediately, no clock, immediately. And this one is going to set the flip-flop immediately. But wait a second, man, so now it became a latch. No, because it's not the normal operation. The normal operation, we will use T. Okay? We are going to only use this input, okay? And usually in initialization or when you want to clear it immediately. This is not the normal operation. Okay? For example, in initialization, I want to start from 1 or I want to start from 0. So I don't want to wait for the clock. I want its action to be taken. But this is not the normal. It's the normal, or this is not the synchronized normal operation. Synchronized normal operation is when you use D. Okay, guys? So again, let me say it again. We can add 2 more inputs. These inputs are gonna make set or clear immediately, not waiting for the clock. And this usually used for, this is not the normal operation. We use it just in specific cases, like for example, just as initialization. Okay, I don't want to for the clock. I want the action to be taken now, not wait for the clock. Like initially, it's not the normal. Okay, so that is why we can add 2 inputs this way. And as I told you before, when you find one input with a bubble, what it means when you see a bubble, what it means? It means it's active low. So this action will be taken in active low. That means if I want to clear it, I have to input 0. If I want to set it, I have to input 0 because it's active low. Can I design it to make active high? That's for sure, yes. You can design to make it active high. So in this case, when it is 1 clear, 1 is preset. Is that okay? But here in this case, so if you have a chip or in the coming lab, if you look at the chip and you find, for sure, clock is basic, okay, Q prime, Q and G. But sometimes we have sometimes, okay, so maybe when you buy a chip, maybe it does not have a clear, it does not have a preset. That's why it's not essential, okay? But sometimes they give you this option so that if you want to clear at any time, you can do that without waiting for the clock, okay? This is, you should understand, guys. So when you apply 0, yes, I will get 0 here, yes, but at the clock. But this is something I want to do it immediately for some reason. I want to do it immediately. That's why if I put here 0, I will get 0 immediately without a clock, immediately. What I'm saying? Again, this is not the normal. This only happens when, for example, for initialization, or you want to clear it immediately. When you want to clear it immediately. Any questions? So here, guys, Look here. When you put here 0, you have to make sure you put here 1. Because you cannot sit and reset at the same time. Doesn't make any sense, right? So if you put here 0 to clear it, okay, you have to put 1. And this action will be taken immediately. Is that okay? If I put here 0, I have to make sure there is a 1 here, because this action should be here you set, because it's active low, and the action is taken immediately. For sure, if you put 0, 0, this is a funny. You should not do that. It doesn't make any sense. It doesn't make sense. It doesn't make any sense to clear and set at the same time. It doesn't make any sense. So almost. So here I can see, guys, we have 4 cases. Okay, let me explain it this way. We have 4 cases. The first case, if you have 0 and 1 here, okay, and in this case you are gonna clear immediately. Okay, and the normal operation is not gonna work. The normal operation is not gonna work because it's gonna be 0 all the time. Okay. So even if you put 1 here, it's going to continue 0. It's like this one has more priorities than anything else. Okay, now, if I put here 1 and I put here 0, so that means I'm going to set it. So it becomes 1, regardless what is D. Okay? Now, 0, 0, this is forbidden. You should not use this case. 1, 1, this is the normal operation for D flip-flop. So if I put here 1, 1, if I put here 1, and I put 1, so this is the normal operation. That means if you put 0, you will see 0 at the clock. If you put 1, you see 1 here at the clock. Any questions? Okay. So yeah, that's why, look here, guys. Also, I give you a diagram here to understand better. Number 1, this time, I should not keep my eye only on the clock. Also, I have to keep my eyes on the clear and clear and set, because this happens immediately. So look here, guys. Number 1, in the very beginning, you can see here, this is 0 and this is 1 here. So because the clear is 0, okay, so it has to be clear, okay, regardless what is D. This is not the normal operation. Even if D is 1, D is not working at this time. Right? Even if G is 1, still I get 0 because it's clear. This is not the normal operation. Because it's not the normal operation, you should not even look at G or even look at the clock immediately. Okay? So that's okay. Now it is 1 and this one is 1. So this part from here to here, this part, because 1 and 1 until here, this is the normal operation. Because you can, from here to here, this is a normal operation. Because you can see here, this one is high, 1, and also here, clear is 1, and this one is 1. Now it's a normal operation. Normal operation, so here I'm going to look at these times here, and also these times here. Okay? So at this time, D is high, so this one, as this time here, yeah, D is high, that's why you can see here, I made it high. Okay? At this time here, okay, D is 0, that's why I made it 0. Because this is the normal operation. But now what happened after that, you can see what happened here. This one went low. And this part is very important. So you can see here, guys, this one went low here, okay? So I'm not gonna wait the clock. There's no clock. This is a most important thing. So here, the set, now it is set. Because you can see here, this one is 0, this one is 1. So here I'm making preset. So I'm not going to wait for the clock. Look here, it happened between the 2 clocks immediately. You got what I'm saying? After that, it becomes 1 and 1. 1 and 1 normal operation. This is the normal operation. So when this one is high, this one is 0, I'm going to get 0 here. Okay, guys? Don't be confused. This clear and preset is not the normal operation. You can use, again, it depends on what you want to do. You may not need to use it, okay? But this one is an option you have. The thing here is that if you want to clear immediately, I don't want to wait for the clock. Like for example, initialization. I want to start from a certain value, 1, 1, 1, or 0, 0, 0, 0, okay? You can use this one. Don't wait for the clock. If you want to take some action immediately, you can use clear and preset. Any questions? One of the things also some flip-flops may have, okay, we can have enable as well. So some flip-flops, they have enables. In addition, so again, I told you guys, in case of D flip-flop, these are the basic ones. D, Q, Q prime, and Q. These are the basic ones. Sometimes we add clear, sometimes we add set. Sometimes, okay? Also, sometimes we add enable. So that's why in the coming lab, you need to read the data sheet to see what are the inputs of the flip-flop. Okay, so you can design it to add enable. So it's gonna be the same thing. If, for example, here, this enable is active high. There is no bubble here. This one is active high. That means if I make 0 here, if I put 0 in the enable, so actually the flip-flop is disabled. That means no change. In disabled, no change. So even I put 1 here or I put 0, is no change. Okay, no change because it's disabled. But if I put here 1, now it is enabled. The other way, if also I want to tell you something interesting here as well. If the flip-flop does not have enable, I can make enable. That's what. So this one it already has an enable. But what I'm saying right now is this one has an enable. What I'm saying right now is if it does not have an enable, I can make an enable. You know how? Look here how I make it. This is the clock. You know, if there is no clock, it's no change. It is disabled. So if you don't have a clock, it's going to be similar to disabled because actually it's going to be taken at a certain point. So if I don't allow the clock to enter the flip-flop, I disabled it. Okay? And that's exactly what I'm saying here. What I'm saying here, guys, if it does not have an enable, I can add it this way with a clock and I input the clock here and enable here. So that look here, when the enable is 0 and have a clock, so I'm going to input 0. When you input 0 here, that means there is no clock. There is no clock means no change. It is disabled. You got it? But if I put here 1 and the clock, you will get the same thing. Okay. So what I'm saying here, guys, sometimes the flip-flop has an enable. We should understand how it's gonna work under enable. So it's gonna work this way. If the input is 0, that means this one. This one is disabled. That means the output here, for example, if it is 1 1, no change. It's gonna continue 1 1. So this is not gonna work. So even if you put 0 or you put 1, no change. You are not gonna see change. Is that okay? But if you here, if you put here 1, so now it's gonna work normally. And if you don't have an enable, if the device itself it doesn't, or if the flip-flop itself does not come with an enable, you can add it externally, something like as I did here. So that when the enable here is equal to 0, you are gonna block. I'm gonna block the clock. And it's gonna work, it's gonna work at specific times. So if there is no clock, it is disabled. It's not gonna work if there is no clock. But if I put here 1, I will see them. Any questions? This is for D flip-flop. So the first, as I told you guys, I'm gonna teach you 3 flip-flops. The first one is D flip-flop. Then I'm gonna explain JK flip-flop. After that, I'm gonna explain T flip-flop. Only three types of flip-flops. Very important. That's what we're gonna use in this chapter and next chapter as well. Okay. For D flip-flop, this is the easiest one. All of them should have clock. All of them should have clock for sure because any flip-flop should have clock. They can also, all of them can come with enable, come with clear, come with preset. This is something optional. It may come with them or not, optional. Okay. That's why maybe in the coming slides, I'm not gonna talk anymore about enable, but that doesn't mean I cannot make JK flip-flop without enable. It doesn't mean, okay? Or it doesn't mean I can't make JK flip-flop with set or preset. It doesn't mean that, okay? But just I'm gonna focus on JK, but also it can come with the optional stuff, okay? So D flip-flop is very easy because in D flip-flop, Q is equal to D. Very easy, Q is equal to D. If D is 0, you store 0. If D is 1, you store 1. But at specific times. Any questions? Okay. Let's look how JK flip-flop works. Okay. First of all, I want to answer a question. Why you explain 3 types of flip-flops? Is that enough to have only one type and you just use it? So sometimes it depends on what you want to do. For example, if you want to make like a counter, something that counts, okay, as we will do later, usually T flip-flop is better. Usually T flip-flop is better. So actually, yeah, so it depends on what you want to do. So yes, sometimes one of them, or if I want to design a certain circuit, I have the option to use any one of them, okay? But also you need to know all of them because we actually use all of them, okay? So here, let's see JK flip-flop, okay? This is how it looks like. Look here, guys. Number one, we have here Q. We have Q prime. Okay, this is as normal as usually. And then you have a clock. Yeah, I should have a clock because it's a flip-flop. And this clock is rising or falling. There is no bubble rising. So here action will be taken at rising edges. Okay? And now on top of that, here in JK flip-flop, I have two inputs. Not one input, J and K. So in G flip-flop, I have only one G, only one. But here in this case, in case JK flip-flop, I have two inputs, J and K. Is that okay? How it works and how you can create it. Okay, let's look how it works. It's very simple. Look here, guys. Number one, if it is 0, 0. Okay. Look here, if J and K 0, 0, I have two inputs. If you put 0, 0, so actually no change. So 0, 0 means no change. Makes sense? Then, if K is 1, and J is 0, so if here you put 1 here and 0 here, so actually this one is like a reset. This one like a set. So what happens here, you reset. But if J is 1 and K is 0, you actually set. Okay, what about the last case, 1, 1? Is that forbidden? No, we don't have anything forbidden here. So 1, 1 actually is gonna make a toggle. Toggle. You know what toggle means? You complement the stored value. So if the flip-flop is storing 0, when you toggle, it stores 1. If the flip-flop is storing 1, when you toggle, it stores 0. Toggle. So now, guys, I have 4 options here based on the value of J and K. If I put 0, 0, no change. This is the first option. If K is 1 and J is 0, so actually you are going to make a reset. If J is 1 and K is 0, okay, so actually you are going to make a set. If it is 1, 1, we are going to make a toggle. So it's a new option, toggle. So you can complement the stored value. Any questions? Okay, guys. Okay, so that's enough for today. We're going to meet on Tuesday. Okay, I will continue this. Thanks.